Good morning, everyone. Myself is Moin Akhtar. I'm a physics lecturer in National Bio Science and Commerce College, Baswanagar, Hubballi. So today I'm going to teach you how to find the refractive index of a glass by using glass slab and traveling microscope. So this is our today's experiment. So in this experiment, we are finding refractive index of a glass by using glass slab and traveling microscope. Okay. As already I have mentioned, so today we are performing experiment, that is 14th experiment of second PUC, that is the refractive index of a glass. So here the aim of the experiment is to determine the refractive index of a glass using a glass slab and traveling microscope. So this is a glass slab. So as in theory classes we have studied about refraction of light. So to study the refraction phenomena we are using a glass slab. So this is a glass slab. So this we have to use. And this is a traveling microscope. This is a traveling microscope. So we will use this to find the refractive index of glass. Next 11. See, on which principle we have to perform this experiment? Refractive index of a glass with respect to air is the ratio of real depth and apparent depth. In theory classes we have studied about real depth and apparent depth. So refractive index is the ratio of real depth and apparent depth. So on this principle we have to perform this experiment. Then, so which formula we are going to use in this experiment? So to find the refractive index of glass, see, they have given the formula. Ng is equal to R3 minus R1 divided by R3 minus R2, where R1, it is the reading of traveling microscope when focused on ink mark. So here you can see. So this is a traveling microscope. So this traveling microscope will focus on this ink mark. So here I have made ink mark at the bottom of this traveling microscope. So through this microscope we will see the image of this ink mark clearly. So at what reading, see, so here there are two scales in the traveling microscope. This is a mean scale, it is this one horizontal mean scale, this is horizontal vernier scale. So when we move this traveling microscope right and left side, so we have to see the reading in this scale. So here what we are doing, we are fixing this traveling microscope at a particular position. So we are moving this traveling microscope up and down. So for that reason, so here in vertical way also they have given a mean scale and vernier scale. So after adjusting traveling microscope to see the clear image, so corresponding main scale reading and vernier scale reading we will note down. So that will be your R1. Okay. Next. So in this formula R2 they have given. So what is this R2? R2, it is a reading of traveling microscope when focus on ink mark through the glass slab. See, so next step what we will do, so we will keep this glass slab. Okay, after adjusting this traveling microscope on ink mark, so don't disturb it. So just keep glass slab and then try to see the image of ink through the glass slab. So this time we will observe after keeping this glass slab, you will observe. So the image of the ink mark, it will appears blur. So to get magnified image of that ink mark through the glass slab, so this knob we have to use. So here they have given this knob. So this knob we have to rotate in an anti-clockwise. So after that what happens, this traveling microscope will move up and down. So at a particular position, means at a particular reading on mean scale, so again you will get a clear image of ink mark through the glass slab. So that will be your R2 it is. Okay. Then next R3 is what? So after taking R2 reading, means after seeing the clear image of ink mark through the glass slab, after that what we have to do, don't disturb it, just put the chalk dust on the glass slab like a thin layer. So how much dust we have to put on this glass slab? So it should form a thick layer of dust. Okay, like this we have to spread the chalk dust on the glass slab. Okay, so after that what happens, so this time you won't get the image of ink mark. So this time what we have to see, we have to see clear images of dust particles through the glass through the microscope. So for that again what we have to do, we have to rotate this knob in anti-clockwise, so until you should get sharp image of dust particle. So when you get the sharp image of dust particles, so that time whatever reading you are getting in a mean scale as well as in a vernier scale, that will be your R3. Okay, so here, so it is clear R1 is what, R2 is what, R3 was. Okay. Now the question is R, how we can calculate it. So for that they have given second formula. Reading of triangular microscope is equal to R is equal to, that means R, this common formula we are using for to calculating R1, R2 and R3. So this MSR means main scale reading, CVD means cone side division, and CL means LC means least count of this triangular microscope. So this formula we have used. See, so this is the image of, this is the diagram of triangular microscope, ray diagram they have given. This is a ray diagram of triangular microscope. Okay, so here at the, so this is a glass slab, this is a triangular microscope, so which we have kept it at the base of the triangular microscope, base stand of the triangular microscope. Okay, next, before going to take the readings, before going to start this experiment, first we have to find the least count of this experiment. Okay, how we can find that least count? See, pause ಮಾಡಿ. So first we will see how to calculate the least count of this triangular microscope. So in the observation you can see, see first point they have given an observation, value of 1 MSD. Okay, see, you can see, so this is mean scale. So you can see, after focusing you can see, so from 0 to 1, just we have to see how many lines are there. So you will see 20 lines. From 0 to 1 there are 20 lines. So they are asking what is the value of 1 MSD, what is the value of one line, each line. So if you divide 1 by 20 you will get a 0.05. So the value of 1 MSD is 0.05. Okay, next, number of division on vernier scale. So this is, so which was clear earlier. So after keeping this glass slab you will observe that image appears blur. So to clear or to magnify that image, what we'll do, so we'll not use this knob, so we'll use this knob. So we'll rotate this in anti-clockwise, so it will come up. Okay, so at a particular position again you will observe sharp image, so there we have to stop. Again you have to take a MSR CVD, then again you have to use that same formula. So this time that R we have to consider as R2. So MSR CVD we have to see, and then that reading we have to take, and then we will calculate the R2. Similarly after that what we'll do, we'll spread the chalk dust on this glass slab without disturbing the setup. Okay, a thick layer should be formed. Up to that we have to spread the chalk dust. Okay, then after spreading chalk dust on the glass slab, so the image which you have seen clearly through glass slab, so this time you won't see the image. Okay, so this time what we have to do, we have to try to see the dust particle clearly. Okay, so for that what we have to do, again we have to rotate this in anti-clockwise, it will come up, and then at a particular position you will see the clear image of dust particle. So there you have to stop, and then we have to take the MSR value, CVD value, then those value we have to take, and then again we have to substitute in this formula that R is equal to MSR plus CVD into this count. So that will be, this time this is your R3. So after getting R1, R2 and R3, what we have to do, we have to use this formula. Ng is equal to R3 minus R1 divided by R3 minus R2. So R3, whatever answer you got here we have to note down. R1, whatever answer you have got, we have to subtract from R3. Okay, then again in denominator we have to write R3, then R2 value whatever we got here you have to write, we have to subtract. So after subtracting you will get some value. Okay, so after dividing you will get your answer in between 1.33 to 1.55. So approx answer you will get the exact refractive index of glass. Theoretically it is 1.55 it is. Okay, so this is how you have to do this experiment. So here this experiment complete. Thank you. So in today's experiment we have performed refractive index of glass means the aim of the experiment is to determine the refractive index of a glass by using trivalent microscope and glass slab. So that we have found it, and theoretically value of refractive index glass is 1.5. So your answer should be in between 1.33 to 1.55. Okay. Thank you. Thank you. Have a good day.